Good morning to all. Today we are going to study about minimum and maximum mode system and its timing diagrams. This is a very important topic of this unit, and this is a very important question in the unit 2 in both internal as well as external, because this describes how your microprocessor will be working. This describes how your other peripherals are being interconnected with the microprocessor and how they are able to control the processing of data. In the previous session, we have studied about I/O addressing capabilities and special processor activities. Okay, so as you all know, microprocessor is a processor which performs some tasks according to the user need and takes the data from the memory and reads or writes the memory and I/O read as well as I/O write. So before going into detail about the minimum mode system and the maximum mode system, so this is the pin configuration of 8086. As you all know, it is a 40 pin IC. So overall we have 40 pins in this IC. So each pin will be working according to its work. So like VSS nothing but ground, so this pin will be acting as your ground pin. So like that we have 40 pins. Each pin is assigned a particular task, right? So as you all able to see here, from AD0 to AD14, from pin number 2 to pin number 16, these are, and AD14, then AD15 up to AD15, from AD0 to AD15, these are multiplexed pins, nothing but they are multiplexed with address and data bus. Address and data bus AD0 to AD15 are multiplexed address and data pins. So they can be used as address or data bus. They are being multiplexed with address and data bus. Similarly, now coming here we have NMI 17th pin, which is called as interrupt pin, which is full form is non-maskable interrupt. Non-maskable, maskable nothing but hide. So it can be hide, or it can't be erased, or it can't be removed once it occurred. Next pin is int R, nothing but int request, nothing but interrupt request. So whether if interrupt has occurred, interrupt request pin will goes high. Next clock pin, here the clock is being given to this pin, nothing but clock pulse. What is the purpose of clock? As we all know, it is the most important thing in the digital world in order to do its task. Without this, it can't be able to do a single task. So clock must be given with the help of a clock generator of certain megahertz of frequency. Next we have one more ground pin, which is 20th pin. Nothing but from 1 pin and 20th pin are acting as your ground pins. Similarly, from 21st to some 31, this 21 to 31 pins, they will be varied depending upon whether your 8086 is acting in minimum mode or it is acting in maximum mode. So depending upon the mode, the pin configuration will vary from 21 to 31. From 21 to 31. We will be able to see these pins in detail in the next few minutes. Next, we have 32 pin, which is read bar. So read bar, nothing but it can able to read if it is 0. It can be read from memory or from any IO bus. So this is the pin which is the control pin for reading the data from the memory or reading the data from the IO. Clear? Next, 33rd pin, which is very most important pin in today's concept, which is minimum mode system and maximum mode system. MN by MX bar. MN by MX bar is a pin which decides that 8086 processor is being working in minimum mode or else maximum mode. So for assumption, MN by MX bar is equal to 0 if you assume. If it is 0, then MX 0 bar, MX bar, nothing but 0 bar is 1, 0 complement 1, MN is 0, nothing but MX, if MN by MX bar is equal to 0, nothing but MX is active, nothing but 8086 operates in maximum mode. Clear? MN by MX bar is equal to 0, maximum mode. If MN by MX bar is equal to 1, then 1 bar 0, this is 1. So MN is being activated, nothing but 8086 operates in minimum mode. So what is this minimum mode, maximum mode? We'll be seeing later. But for now, this is the pin which decides whether it is operating in minimum or maximum mode. Next, 34th pin is your bus high enable, which we have seen as the status pin for your address banks. Even address bank, odd address bank, low address bank, high address bank. For high address bank, we have bus high enable. Okay. Next, 35th, 36th, 37th pin, 38th pin. These are 4 other address pins because we have address as 20 bits. So we should have 20 pins. A0 to A15 are being covered with multiplexed with data pins, whereas the 4 remaining pins are taken as 35, 36, 37 and 38. This can also be acting as your some status pins, which are S3, S4, S5, S6. This we will discuss when time comes. Up to here clear, 39, 80, 15 and 40th pin is VCC. So 8086 operates with plus 5 volts. This is the pin configuration of 8086. We have 40 pin in your 8086. So these are the 40 pins of your 8086. So you see what are the common signals what we have. As I told to you, AD0 to AD15, they are bidirectional, nothing but being address or data bus. They are multiplexed address or data bus. So if you want to transmit the memory, take the address bus. If you transmit the data, take the data lines. Clear? If the data are to be transmitted, so in this pin, give to the data bus. If the memory address has to be transmitted, take the address bus. These are the some common pins. Next we have A16, A17, A18, A19. These are the higher order data bus, address bus, sorry. because we have address as 20 bit, so 20 pins should be there. So A16, A17, A18, A19, the higher order 4 bits will be stored into these registers. Next we have a bus high enable status. It activates the upper half, yeah, because it is a high address bank, so high address it will able to activate. So this means nothing but your active low signal. Okay, it is multiplexed with status signal S7. Similarly, yeah, this mini M1 by MX bar, nothing but this tells what mode the processor is operate in. Read, which is used to read operation, it is an active signal, active when low, it is an output signal. Test is nothing but it is one of the feature in our special processor activities, where test is being given by the wait instruction. So it will wait until the test has been done of the external activity. Next, ready, yeah, this nothing but acknowledgement bit which gives the processor that it is ready for the next thing to do. Reset, it causes the processor to again reset, to immediately terminate and stop the current execution and start fresh. But thing is, when it must be active high for at least 4 cycles, 4 clock cycles, because 8 bits. So after each reset, 8 bits will be cleared. Next, clock, it gives a clock. Next, interrupt request. This is the triggered input, nothing but this is sampled during the, if any interrupt request is pending, the processor enters the interrupt acknowledgement cycle. The signal is active high and internally synchronized depending upon the interrupt has been occurred. NMI, non-maskable interrupt, and VCC, power supply plus 5 volts. So this is the pin configuration in our 8086. Thank you.